Yeah, before we move to other topic or to other components, I would like to point out that in your rechargeable lamp, there is a conversion of AC to DC. So when you connect your rechargeable lamp to power supply, you charge it, right? This is how the circuit looks like. There is something like transformer there. They don't use transformer for such rectification to save costs. So they will remove transformer. Let's remove it. So and they will connect the AC. As when they connect like this, so they connect like this. So now let's play it. See the output, 14 point something, right? 14 point something. Okay, let me check the footage. What was the footage? Okay. It's from 220 volts. Okay. I think there's something wrong with So now, if you connect the B rectifier directly to the power source, we have something like this, like 99 point something. Actually, in real life, we have something like 1 something, close to 200 volt output. So you will use a capacitor to filter the output of the rectifier, and then instead of connecting it like this directly, so at times we connect like this thing will explode. So let's check. Okay, explosion. It should explode. So what to do is just to use a resistor. Use a resistor to limit the flow of current to the bridge rectifier. So let me rotate it. Okay, yeah. So now let's use the resistor there. So now, okay, delete. Let resistor be something like 10k. Okay, let's play it and see what happens. So the resistor exploded. So let's change the value to like 100k. Okay, 100k. Okay, let's play it again. So it exploded again. So let's change the value again, once again. So now there's no explosion, so it works. So but let's reduce it. The footage is too small. So let's reduce it to like 2 something and see what happens. So it exploded. So I think we should change the wattage. So we can change the wattage to like maybe 2 watts. As I told you in the previous video that the wattage of a resistor is a function of its size. So its wattage depends on how big the resistor is. So let's use this now. No, it works. There's no explosion. So let's change it to 100. So and see what happens. Explosion? No explosion. So let's change it to okay, let's change it to 10k and see what happens. Explosion, push. No, there's an explosion. Okay, let's go back to 5 watts. Okay, 5 watts. Okay, let's play its explosion. Okay, so actually this is the circuit. So there is something wrong with the simulation. So but in real life it will work. In real life. So 1 watt is enough. Even half watt is enough in real life. So it should work like this. So you can use something like 100k instead of 200k. So and the capacitance. So use 104. We see 104 on it. 104. Or you can open your rechargeable lamp to see the circuit. You see a circuit, you see a capacitor and a resistor like this. So RC circuit. So you see it there. So, but make sure that the voltage rating is like 400 volts, so that it won't get spoiled. So it won't get burnt. So and then after this, so you put your battery here. So your battery, you put it here instead of voltage. So the AC will be charging your battery. So after going through the rectifier, so it will come out. It will be fitted by this capacitor. So that means your battery should be here also. Your battery should be here. So yeah, you put your battery here. So it will be charging as you connect it to the power supply. It will be charging the battery. So but I won't. Okay, let me cancel the explosion. So now let's play it. So it will come up now, but the only problem now is that even if we put let's put a switch here, even if there is no power supply, the thing will be on. So even without closing the circuits, without applying any input, any power supply, you still have an output. So the reason for this is that the battery is also connected directly to the power supply. So then we have to have a means of controlling this. So then with normal circuit for it is, let me show you the normal circuit. Oh, okay. This one is also correct. It's correct. It works, because normally when you switch on when you plug your rechargeable lamp to the socket, it should on. So since the battery is there, so you just have to put a switch here also. So the switch to control your LED array. So there's nothing wrong with the circuit. So it works. So if you close this, it will work. So that means when you connect it to the socket, it will be charging the battery. But the only problem here is if you want to do an indicator, so to indicate that the battery, the lamp is connected to the socket, is charging. So in that case, you need to use something like a diode to control the flow of current. So let me show you this control safely. Okay, yeah, let's put it here. Okay, rotate. Okay, yeah, this okay, a resistor. We need a resistor. Yeah, okay. See now, even let's open this. That means with or without power supply, the LED, the indicator will be on. So to solve this problem, the reason why it is on every time is that the battery is also feeding it back. So for us to rectify this problem, we need to use a diode to stop the flowing back of current to the indicator. So let's put a diode there. Okay, delete this. That means current will be moving to the battery, but it won't be allowed to move back. Hope you get the gist. So let's just reverse it like this. Okay, current will be moving from higher potential from this point to the battery, right? So from this point to the battery. Okay, let me move it up. Okay, yeah, to the battery, but it won't be allowed to go back from the battery to the source. Okay, now if you don't apply voltage, so it's not on. So this is the indicator and this is the correct LED, the real LED array that want to be using the battery or the rechargeable lamp to turn on. So that's all for rectification and design diode and some other things that are related to diode. So now our next lecture we will discuss capacitor and transistor. Alright, thanks for watching.